For this extended response question, we're being asked to do a multitude of things, and one of the things that we are expected to do is to read this graph and answer questions related to it. Now, the key strategy to this particular question is probably not to put all of those dots into your calculator. I know that's quite tempting to be able to do, but probably don't have to. So let's go and have a look at what it says. So it says here that the number of cars requiring a tow truck in the city of Melbourne is recorded against the rainfall for 10 weekdays. A scatter plot of the variables is shown below, and we can see here this is quite clearly forming some sort of non-linear curve. It was decided that the data shown in the scatter plot of question 1 is not linear. In the attempt to transform the data to linearity, a reciprocal transformation of the independent variable was undertaken. So let's have a look at this piece of nonsense here. Reciprocal transformation of the independent variable. Again, sounding very much like it came out of the words of J.R.R. Tolkien or something like that. We shall have the reciprocal transformation of the independent variable, said Gandalf. No, what that means is that we're going to do a 1 over x transformation. Remember, as soon as you see the word reciprocal, I'm just going to adjust my ties. I realize I'm a bit slovenly there. As soon as you see reciprocal, that means 1 over whatever it is. And the independent variable, as soon as you see independent, that's the same as saying explanatory. And that, of course, is going to be x. State one other type of transformation that would be appropriate in an attempt to transform the data to linearity. Well, and what that's asking here is we need to go and refer to our circle of transformation. So whichever one looks awfully like this. So we can see here, it's going to look at that top one. So the one that they have said here is they're going to use a 1 over x. We have the choice of saying either y squared or log x. Just for the lols, I'm going to say y squared as my option. I could have also said some manner of log, but this will do. The equation of the least squares regression line for the transformed data was found to be number of cars towed equals negative 108.96 divided by rainfall, just in case, plus 57.02, where r is equal to negative 0.97. Now, this equation, I should tell you, is the same as every other equation they've done. They've just gone and buggered it around. They've gone and flipped everything around. Way you would normally see this is that you would say number of cars towed equals 57.02 plus, or in this case it's a negative there, so we can get rid of that plus there, minus 108, there's a little random dot on there, let's get rid of that, 108.96 times 1 over rainfall. So I just wanted to do that because sometimes when you look at this, you go, what on earth is that all about? Well, that's what the actual transformation is. Where r is negative 0.97, well, that's a very good correlation. If you remember, that's getting close to 1. So that's going to be a quite strong. We would need to see the residuals in order to confirm that. According to this model, find the expected number of cars that will require towing when 13 millimeters of rainfall is recorded. Round your answer to the nearest whole number. So we'll just need to do a good old substitution here. So the number of cars. Now you can use either of those equations that I've written. May as well just use the one that they've given us. So it's negative 108.96 divided by 13 millimeters. Now we need to make sure. Oh, thank goodness. I panic about units, whether or not they're going to be annoying and change the units on you. But yes, it does say millimeters here, it does say millimeters there. So 13 plus 57.02. So we can plop that into our CAS calculator like so. Let's get my old keyboard up. We get 48.638. Now, the question there says, round your answer correct to the nearest whole number. So this we'll need to round up because it says 48.6. So that is equal to 49. 9 cars. A residual plot resulting from fitting the transformed model given above to the transformed data was undertaken. An incomplete residual plot is shown below. The residual for the plot 1351 is missing on the residual plot. Find the residual value for 1351. Round your answer correct to the nearest whole number. So with residuals, so we're wanting to put something on the residual plot. So just as a reminder, a residual is the actual value, take away the predicted value. And when I say actual value, I mean this one. And the predicted value is when I substitute that number in there into the equation. So that's a little x there, by the way. That's the y. So let's get our little predictor. So the actual value here is going to be equal to 51. And we're going to minus, and we're going to substitute this number 13 into that original equation. So that original equation from memory is, and I'm going to put brackets because it's got a minus in there, 108.96 divided by 13 plus 57. Oh no, it's not 13, dear. Oh no, it is 13. We've already done this. There you go. We did it up here. Well, fiddly-dee. 57.02. So 51. But it's always nice to put my arithmetic in there. That's me covering up for the fact that I just did some unnecessary bit of work there. 49. Because we may as well use our... So the VCAA expects you to use the unrounded figure every time. So this was 48.63846154. And so if I just do 51 minus ants, it's 2. Correct to the nearest whole number. So 2.36, which should get us a very lovely value of 2. So we need to, it does say to plot the missing point. So don't forget to always fulfill all the instructions that they have said. So we want, where are we going? 1 over x, and then we have to fill in this. So we know that the value is 13, so we want 1/13, because we're substituting x in there. So you'll notice there's no 13 along here. 1 divided by 13. So that says 0.0769, so 0.08. So I'm going to look for 0.08, which should be about here, according to my scale, and I'm going to put a big old dot right there. And we can all see it because that dot is so big that it is super clear. So we had to calculate the residual, and then we had to plot it. So what's this last business say? Use the residual plot to explain why the reciprocal rainfall transformation is an appropriate model for the data. Well, this is where we get to use our wonderful ability to explain this using our templates. As there is no clear pattern in the residual plot, there is an assumption of linearity.